Right. Can you see my screen? Hello.
Yes, sir. I can see
Yeah, you can see, no? So I'm changing
the
the
program.
connection. So wait, I'm changing the connection, network connections. Okay, you can see it now, no?
Yes, sir.
Right. Okay. So chapter is programming. Actually, under this we will be learning how we can instruct the computer to do something because what we are doing usually is just using the programs. Some people have developed programs. For an example, MS Word, Excel, Photoshop. Likewise, those are already developed programs by some programmers, and we call actually software. So, may I know the difference between software and program? So, do you know the difference between software and program? What is software and what is program?
Mm, software programming. Uh, Programming means giving command to a computer,
Hmm.
like uh,
Programming means giving command to a computer. What is software?
mhm. uh, software. Uh, a collection of
Hmm. Yeah. Okay.
uh,
Correct.
maybe
Basically,
program.
program means you can call the program as like, so you can write this as PROGRAMME. So that is one thing, and sometimes we are using US English and we are writing like PROGRAM. So this is how we are writing computer program basically. So software means related or an interrelated programs and interrelated programs. Maybe it can be one or more works together to perform specific task. So we call it as a software. Interrelate programs, and those are work together to perform specific task, right? So then program means a set of instructions to a computer. A set of instructions to a computer is called a program. So it is actually a collection or set of instructions to a computer which instruct how to do something using data and using using other applications. So likewise, so it instructs the computer uh, to do a specific task. So, but
Mm.
here it's like one or more programs, uh, one or more interrelated programs. We call it as a software. So, for an example, we have MS Word interface here. In this, if I click, okay, if I click this one, it allows me to change the font. So, this is one program. Change in font is one program. So, if I press Control P, Control P will display print dialog box. Control P will display print dialog box. That is one program, that is printing. So if I press
Mhm.
Control S, what will be displayed? Control S, it will display save dialog box. Control
Yeah.
P will display print dialog box. Those are programs. Printing is program, saving is a program. Likewise, we have different interrelated programs together, working together with MS as MS Word application. But that application is a software. It is one or more programs. But in a single program, you have a set of instructions to a computer. Actually, these are set of interrelated instructions. Set of interrelated instructions. Hopefully, so now you can understand what is program and what is software. Okay, then, to develop a software, we have a process. We cannot just develop a software. To develop actually software development, it is a kind of complex process. So why I'm
Uh-huh.
telling software development is a complex process? Software programs are critical. So those are actually the information is the most valuable resource in the world. Basically, nowadays it's not gold, it's not fuel. Information is the most valuable resource. So why? So for an example, you think that if somebody knows the how to heal corona or COVID, so that is information.
Uh,
And
yeah.
if a particular company can develop a drug to heal this quickly within 1 or 2 days, that is really worthier than, that is really valuable than fuel and gold, whatever exists in the world, platinum. So that is valuable because information, that information itself is a resource, right? So it
Yeah.
is a valuable resource in the world. So we call it is most valuable economic resource in the world in the new technological era, right? Therefore, the software deal with information. No? Okay, think that. So you have bank account in Swiss bank or some other bank or even local bank. So you have account. So what is there actually? Do you have money in the account or related information?
Information.
Information, no? So why we call it? So we withdraw money from the ATM, that is true, but inside your account, you don't have money. Physical money, you don't have. So it has a figure. It has a figure.
Mm.
It has a figure saying you have 100,000 balance in your account. That is a figure. That is information. When you withdraw, you will get physical money from
Yeah.
ATM. That is true.
Yeah. Sir.
If some
Sir,
way,
wait. Sir,
yeah. Shall I continue?
sir. Yeah.
Okay. So, okay. If for an example, we said that in the account, so you have money, it indicates by the figure which is there in the account, which is 100,000. It shows how, that means the money in your account. Then
Yeah.
assume that somebody is going to change that, change by adding a zero to that. So then your account balance will automatically become 1 million. Someone at zeros. So that is not change in physical money, that is change in information. So you know that how valuable information is, because if someone had few zeros, like 1, 2, 3, 4 zeros to your account, so it will automatically change your living status, no? So you had 100,000 in your account. Now somebody added 4 zeros to your account number, sorry, account balance, means now you have like, for an example, 100 million in your account. Now your lifestyle will really change. So who change that? Initially they have changed the information, but it
Yeah.
affects, yeah, it affects the economic value. So that's what I'm saying. Information is the most valuable resource. Assume that that is a software bug. Bank XYZ, they have installed a software. Okay, due to software bug, so it will automatically add 2 zeros to all the account balances. Software के bug, software के error එකක් තිබිලා account balance
Oh.
එක අගට බින්දු දෙකක් add වෙනවා හැමෝගෙම. What will happen to the bank? Bank will corrupt, right? So simply, so they will really they will have issue because they cannot continue their business because if
Mm.
all, assume that they had 10 million in worth accounts and now it has become 1 billion. So where bank has to pay 1 billion to their customers one day. So but due to that software bug, therefore this software development is very complex process. Even though we use Excel in our home, in our school to do small calculations, Excel can be used in big companies to calculate and store payrolls. Excel can be used to generate management report. Excel can be used to generate government reports. So therefore, it's really critical. So if there's a bug in Excel, that will affect governments, that will affect businesses, companies, and all. So it's not like that Excel bug. If there's an Excel bug, it is affecting our home. Then we can ignore that. But that is not the case. It will affect entire world, right? That's why software development is a complex process. Therefore, we have few steps to develop software. So starting from the first one is you have to find out the problem. We call problem analysis. Then the second step is you have to find out the requirement. The third step, you have to find the way to design the software. We call in the requirement analysis, there are sub step called feasibility study actually. After feasibility study, after requirement analysis, you have system design. After system designing, it is system development. After system development, the next step is system testing, then the deployment part, then you have review and maintenance.
Then software development complex process.
Okay, so it has a complex process, and this is how the process is divided into sub steps. In the first step, so assume that you want to mark attendance. Okay, assume that there's a lecturer or institute, they want to mark attendance of the students. So you have to find out why they want to mark attendance. So then only you will realize or you will understand, because they want to collect the payments on time and they want to track their students, their progress and all. So therefore, they are thinking of marking attendance. So then to mark attendance, what you need? You can assign a person.
Yeah.
Already assign කරන්න පුළුවන්. Or you can assign attendance, you can employ attendance system, so which is already developed one. Or you can employ a barcode system, you can employ a fingerprint system, so maybe face recognition system, whatever, a robot, an automated system, artificial intelligence system. So you can employ anything like that. But before that, you have to find out the feasibility. So if I put a robot to mark attendance, so is it feasible? Can I buy a robot to mark attendance? If I employ a system to mark attendance, අපි හිතමු දැන් අපි මේ attendance system එකේ දාන්න හිතන් ඉන්නේ මේ attendance system එක දාන්න හිතන් ඉන්නේ cleaning කරන කට්ටියට. එතකොට cleaning කරන කට්ටියට මම attendance system එක දානවා මොකක් හරි හිතන්න attendance system එකේ ඒගොල්ලන්ට මම දානවා මේ මොනවා හරි information enter කරන්න ID එක enter කරලා යන්න. But ඒක සමහරවිට ඒගොල්ලන්ට ඒක feasible නැති වෙන්න පුළුවන්. ඒගොල්ලන්ට ඊට වැඩිය ලේසි අර ඇඟිල්ල තියලා අර එක ඒ වගේ නිකන් they need simple mechanism. So they like fingerprint system. So sometimes some people, for an example, these days, so if you put a fingerprint system these days, it will be an issue. Why?
Yeah.
You know
Due
that
to
the
corona.
COVID issue, social distancing problem. So you have to think about that as well. So that is called social or an environmental feasibility. you have to think about economic feasibility. Economically, is it worth? And can I bear the cost? Then the next thing is environmentally and socially whether it is feasible. Then technically whether if I'm going to employ a robot, whether technically it is feasible. Likewise, we have to think which is the most feasible one. So and plus you have to find out other requirements. Requirements means what to mark. Do you mark name? Do you mark employee ID? In time, out time? Whether is it in 24-hour system or AM PM system? ඊළඟට ඊට අමතරව යාගේ ෆේස් එකත් මාක් කරගන්නවද එහෙම නැත්නම් වෙන කවුරු හරි ඇවිල්ලා යාගේ ඇටෙන්ඩන්ස් එක ගහන්න පුළුවන්. So එතකොට යාව රෙකග්නයිස් කරන්න යාගේ ඩෙන්ටිටි එක කොහොමද අපි ගන්නෙ, whether that is true identity. All these are requirements. Understood?
Yeah, yeah.
Then
That,
okay, if you find out the problem, after that if you identify this requirement, then you have to plan properly. Assume that you need a place to live. වාට ගෙදරක් ඕන නැත්නම් තැනක් ඕන ජීවත් වෙන්න. ප්‍රොබ්ලම් එක
yeah.
මොකද්ද? ඉන්න තැන වාට maybe infeasible, you cannot visit, you cannot go to school easily, traffic එක වැඩි, ඒ හින්දා ඔයාලා අලුත් තැනක් හොයනවා ඉන්න. So that is the problem. Problem is you need a new place. The requirements මොනවාද? requirement තමයි ස්කෝලර් ළඟ වෙන්න ඕන, traffic එක අඩු වෙන්න ඕන. So ඕවා තමයි
Yeah.
requirement. ඊළඟට feasibility එකේදී බලන්නේ cost එක කොච්චරද, කොච්චර rent එකක් ගෙවනවද, rent ගෙවනවද, purchase කරනවා නම් building එකක් කොහොමද, ගෙයක් හදනවා නම් අලුතෙන් ඒක කොහොමද. Those are the feasibilities. Then after find out all these things, you are not going to build your house. එකපාරටම ගෙදර හදන්න පටන් ගන්න. First of all you have to plan it. plan එකක් අඳින්න ඕන. plan එක 2D හෝ 3D හෝ plan එකක් ඇඳලා බලන්න ඕන. මේ plan එකට approval එක අරගෙන තමයි ගෙදර ඊළඟට හදන්නේ. So system designing is something like that. You are actually implementing the plan. That part we are going to learn today. අද අපි ඉගෙන ගන්න යන්නේ කොහොමද plan එකක් හදන්න කියලා. මොකද මේවා general steps. Problem analysis, requirement analysis, these are general steps. But system designing, we have specific tools to design the system and specific mechanisms. ඉතින් අපි බලන්නේ කොහොමද plan එකක් හදන්නේ. After planning, after system designing, you have actual coding part. ගෙදරක් නම් ගෙදර ඇත්තටම හදන එක. පාරක් නම් පාර ඇත්තටම හදන එක. But if it is a software, so you have to code. Coding part එක තමයි මෙතනදී එන්නේ. හැබැයි code කළත් බෑ. So ගෙදර හදලත් බෑ, පාර හදලා එහෙම බෑ. You have to test. Foundation එක දාලා ඒක test කරලා බලන්න ඕනේ. ඒක හයි ඇතිද? slab එක දාලා ඒක okayද? ඒක ඔරොත්තු දෙනවද? හරියට වැටලා තියෙනවද? ඒ ටික බලන්න ඕනේ. That is called system testing.
So ඒක කොහොමද බලන්නේ? ඒ කියන්නේ
software එකක් නම් කොහොමද බලන්නේ? අපිට පුළුවන් small component test කරන්න. We call that as unit testing. හරි අපිට බලන්න පුළුවන් font එක වෙනස් කරනවා. දැන් font එක වෙනස් වෙනවද හරියට? That unit is working. අපි save කරනවා save වෙනවද හරියට? Whether that unit is working. Likewise we can check the units. After that we can put all the units together as a single software. MS Word වගේ තනි software එකක් හදලා ඔක්කොම ටික දාලා ඉවරලා then we can test whether entire software is properly working or not. හරිද? එතකොට මුලින්ම unit testing කරනවා ඊට පස්සේ කෑල්ල එකතු කරලා. So we call that integrated testing. You integrate part by part, component by component and test. We call that integrated testing. After that entire system is tested. We call system testing. After that you give it to the user and you test whether user can accept this. That is called acceptance testing. Right? Testing can be done in few ways. Unit testing, integrated testing, system testing and acceptance testing. Whether units are working, whether combined units or integrations are working, whether the entire system is working, then whether that system is working according to user expectations. So that is called user acceptance testing. After all these things, if user is happy with this, we do the deployment. So any process in all these applications. For an example, if you are constructing a road, first you find the problem why you need road, because you have to avoid traffic. Then you find the requirement from where to, so the destination, how you start and all these things. What is the feasible way? Whether you build highway, whether you outsource this process. එහෙම නැත්නම් local කට්ටියට කියලා හදනවද? China වලින් ණයක් කරන් හදනවද? All these things are feasibility studies. So after that you do the planning part. Planning part එකට පස්සේ system development. System development කියන්නේ පාර හදන්න ගන්න. හදලා ඔයගොල්ලෝ දැකලා තියෙනවා කෑල්ල කෑල්ලෙන් ටෙස්ට් කරන්නේ. First it will test individual units whether this area is okay. ඒකේ carpet එක හරිද? That unit is okay. දර පාලමක් හදලා පාලමේ ඉස්සනම ගිහිල්ලා බලනවා. Whether that part is okay. Then integrate. After integrating you test that integrations, combine units. After that system will be tested. Entire system will be tested. After that only they will give it to users, actual users, and test it. So if all are working, if all are okay, then they will deploy. Deploy means they will give it to the particular specific users. Okay, after users are after this is given to users, you have to check whether that is properly working. Time to time you have to check. Time to time you have to check means you have to review. And if there are damages, you have to maintain. You have to check and maintain. Likewise, you have to continue. But one day you will think that this is useless because too much repairs. Vehicle එකක් ගන්නවා, plan කරලා develop කරලා vehicle එක test කරලා test drive කරලා deploy කරා. Then deploy කරලා කාලයක් ගියාම you feel that too much repairs. Software එකත් එහෙම. Too much bugs, too much errors. Then you decide to go back and create a new software. Or go back and construct a new road. Go back and construct a new machine. Go back and construct a new house. So anyway, whatever. So you do this as a cyclic process. No? After this step, you again go to the beginning and start identifying the new problem, new requirement, new system designing, new implementation, new testing, new deployment, handing over, new deployment, again review and maintenance. After some times, you will feel that this is also useless. Let's go for new one. That is a cyclic process, never ending, and that is called SDLC. Meaning is System Development Life Cycle.
Sir, when see the what we are in orals, what we are doing in system oral system design. What we are doing in system
tools.
design.
You want to know the tools that you are using for system designing?
Yeah, no, not like tools, but like what we are doing in system design.
System designing, basically we do the planning part. We construct a plan, blueprint, maybe paperwork or some diagrams. Likewise, we do the planning part. Today we are going to learn that, so you will learn how to do a diagram, how to draw a diagram, and how to design a system using a diagram. Right? This entire process is called system development life cycle. You better write down or take a screenshot if you want. And in case of software, we call software development life cycle. Same thing, system development life cycle. එහෙම නැත්නම් අපි කියනවා software development life cycle කියලා ඒ වගේ process එකකට. Okay, software එකක් නම් software development. Generally ඕනම system එකක් නම් අපිට කියන්න පුළුවන් system development life cycle. Okay?
Yeah.
Right. Actually, this is the next chapter. In the next chapter, we are going to learn that. So that's why I have summarized the next chapter after programming in your book. If you check, there's something called system development. Ne? පොතේ බලන්න programming වලට පස්සේ මොකක්ද තියෙන chapter එක?
It's system development life cycle.
Yeah, system development life cycle. So I have summarized that. Right? Actually, this is bonus because before we begin programming, we have started discussing software development life cycle because that is required before programming. Programming is this step. Programming coming under step number 4. Right? So before programming, you have step number 3, system designing. Before that, you have 2 steps. We are not going to discuss about that 2 steps here. But anyway, we will be discussing about system designing and system development. So in the next chapter, we will discuss about SDLC in detail. But at that time, you should remember that we have already discussed the summary of SDLC. Okay,
Okay.
right.
Sir,
Yeah.
should I write this?
I think I'll share the video because otherwise it will take time. But anyway, this beginning part you can just write down. This is just beginning, no? So a small lesson, no? Better you write down this. Anyway, I'll share the video with you.
Okay.
Quickly write down the steps.
Okay, sir.
Okay.
Wait. Sir, I don't need to write the steps of software development.
Uh-huh.
Should I write these steps also?
These steps.
Yeah.
So if you can remember, that's okay. Otherwise, anyway, I'll share the video. You can just refer the video and write that. Otherwise, it will take
Uh,
some more time. Ne?
okay. Okay. Okay.
Right. Okay. Then let's move to the actual system design in part. For that, I'll refer the book, and that is how this is how the book is given. So first,
Uh-uh.
it tells how to analyze a problem. How to analyze a problem means in analyzing problems, basically what is expected in all level syllabus. So this is different from the actual software analyzing, but anyway, according to your syllabus, what is expected is you have to find out inputs, output, processes. So basically, that's the requirement: processes and decisions. So what are the things that you have to identify? Few things. One is input, second one is output, third one is processes, and as well as decisions, if any. So if you can identify those things clearly, then we call software is properly analyzed. Right. Okay. The problem. This is the problem. Problem definition. Or a step according to the problem definition, you are given the problem. Prepare in letter which can be posted. So what are the inputs? Inputs you can call a sheet or the paper suitable to write the letter, and pen, some glue as well as stamp. So envelope and stamp, those are the inputs. And then outputs, the letter prepared, that is the output. And then, so what is the process? Process means first you have to write the letter, fold and put it in the envelope, then paste in the envelope, and after that write in recipient address on the envelope and stick in the stamp. So those are the steps, and after that you have to post the letter. So likewise, you have to divide problem into understandable pieces, understandable areas. So mainly what you have to identify is inputs, outputs, processes, and decisions. So mainly you have to identify inputs, output, processes, and decisions. So and actually for the diagramming part, we use something called flowchart. For diagramming part, we use something called flow chart. In this flow chart, there are standard symbols because so if you write a big note, if assume that there are like a few programmers, 10 programmers or 10 software designers, they design the software in 10 different ways. ඒගොල්ලෝ සජෙස්ට් කරන එක්කෙනෙක් ඡේදයක් ලියන් ඉන්නවා. අනිත් එක්කෙනා කටින් කියනවා. තව කෙනෙක් පොඩි නිකන් චිත්‍රයක් වගේ ඇඳගෙන ඉන්නවා. Likewise, they suggest different methods to design this. So, for an example, think about housing project, construction project. Construction project වල there are some standard symbols, no? So door එකක් පෙන්වන විදිහක් තියෙනවානේ, window එකක් පෙන්වන විදිහක් තියෙනවා, බිත්තියක් පෙන්වන විදිහක් තියෙනවා, steps පෙන්වන විදිහක් තියෙනවා. Those are standard symbols. Everyone do planning according to that standard symbols. Doors, that standard symbol will be used. Windows, standard symbol will be used. Walls, standard symbol will be used in the plan. Otherwise, what will happen? When it comes to actual constructions, the construction people will confuse. So sometimes if they confuse, they will put a window instead of a door. So they will put a wall instead of a full wall instead of half wall. So likewise, they will confuse when do the actual construction. Therefore, every planner use same set of symbols. Similar to that in software development. So every designer use same set of symbols to standardize the design process. Otherwise, if they are using different symbols or different notations, then that will be really complex process to identify what really required. So therefore, there are some standard symbols. You have to draw that and remember these things. So first thing is how to show the start. It is using ellipse. So we use ellipse to show start and stop or begin and end. So we show it using an ellipse. So that,
Sir,
yeah.
uh, wait, when we talk about the what we call the system, no, software designing,
Mm-mm.
uh, is this the flowchart is a software designing?
Flowchart is software design tool.
Uh-huh.
Understood. It is a technique used to design the software. There are some other software techniques as well, design techniques as well. Flowchart is one thing. There's something called class diagram. There's something called use case diagram. So likewise, DFD, data flow diagrams, ER diagrams. There are different type of diagrams. So this is
They,
one type of tool. Show the data flow decisions මම කිව්වේ inputs output processes decisions පෙන්වන්න and data flow and
sir,
data flow.
then yeah. Uh, uh, when we talk about software designing, is these types of things are we doing?
Yeah, we have to do that. For a very small software we don't need to do that. For an example, think that ඔයාට මේ small දැන් ගෙදර එහා පැත්තේ පොඩි වතුර පාරක් යනවා. You want to cross that.
Oh,
So you want to cross that and you put small kind of maybe මොකක් හරි sheet කෑල්ලක් හරි මොනවා හරි නැත්නම් අර මේ ලී කෑල්ලක් හරි මොනවා හරි පොඩි දෙයක් දාලා ඔක cross කරන්න පුළුවන්. You don't want a plan to do that, no. So that is
yeah,
very initial, very basic thing. But assume
yeah.
that you need to construct you are asked to construct kind of flyover. So which daily which actually so to avoid high traffic area, you are asked to construct a flyover. ඉතින් ඔයා එතන ගිහිල්ලා ටිකක් ලෑලි ටිකක් හරි ලී ටිකක් හරි සිල්වර කොටන් ටිකක් හරි දාලා එන්නේ නැහනේ. So
Fly.
you have to plan this. That is plan as a team, estimate the cost, estimate the budget, find out engineers and constructors. So and as well as different feasibilities, different technologies. Likewise, yeah.
Fly over means
Flyover means flyovers දාන්නේ පාලම් දාන්නේ අර උඩින් පාරවල උඩින්. ඒ වගේ එකක් ලොකු එකක් හදද්දී ඔයා නිකම්ම ගිහිල්ලා නිකන් ලෑලි ටිකක් මොනවා හරි දාලා එන්නේ නැහැනේ, අටවල එන්නේ නැහැනේ. ඒක plan කරලා කරන්න එපා. ඒ වගේ ලොකු software එකක් හදද්දී you have to plan. But very small
Oh.
software, I can order නිකන් numbers දෙකක් විතරක් එකතු කරන්න ඕන. You don't need a plan, you can just go and code that.
සර් එතකොට අර මේ දැන් අපි ඔය A levels වලටත් IT තෝරගෙන ඊට පස්සේ කැම්පස් ගිහිල්ලා software programming කියලා යද්දි මොනවද සර් කරන්නේ?
So same thing, same concepts you will be learning, but with some advanced tools. මේ
ආ
concept තමයි මෙතන දැන් beginning tool එකක් නෙමෙයි beginners tool එකක් නේ flow chart එකක් විදිහට පාවිච්චි කරන්නේ. එතනදී අපි ඊට වැඩි advanced diagramming part එකක් diagrams tools ඒවා පාවිච්චි කරන software designing වලදී user interface design කියලා වෙනම මේ එකක් තියෙනවා UI කියලා UI UX කියලා UID. එතකොට database design කියලා වෙනම part එකක් තියෙනවා database වලට. Program design කියලා වෙනම එකක් තියෙනවා. Likewise we divide this large process into sub disciplines and then we'll learn it in different perspectives, different areas. UX UID is one thing, a database design is one thing, program design is one thing, algorithm design is one thing. Likewise we will divide this to small areas and learn. That's what we do.
Okay, okay.
Okay, right. Then so these are the symbols, you have to remember that, start and stop. So then next thing, so if there's input or output, you denote it by parallelogram, samantarashtrayak, parallelogram use kalla. You can show the inputs and outputs using this. Input, you better draw this, huh? Write down in your book, input, output. You use parallelogram to display that. Then you have the other one, process. To show the process, you use this one. This is rectangle. This is how you show process. Then data flow, actually data flow is shown using these arrows. Using arrows, you can show the data flow. Then decisions will be shown using diamond symbol. This is used for showing the decisions. And next is a connector. To connect a few parts, you use this one small circle, this to connect. This as the connector. Then we have learned few things. So no need to draw this much of large circle, but anyway, connector will be shown. So I'll make it small and write down here the outside of this. This is called connector.
සර් කනෙක්ට් එක වැඩි මේ බලන්න හම්බෙන්නේ නැහැ නේ.
වැඩි connector එක සමහර දැන් ඕගොල්ලන්ගේ book එකේ නම් connectors use කරලා නැහැ වැඩි. But normally we are using connectors, but in your book so we normally they are not using connectors, but it is in some if you are doing A levels and some other degrees, we are using connectors. ඕගොල්ලන්ගේ සමහර තැන්වල use කරලා තියෙනවා, සමහර තැන්වල ඒක අතහැරලා තියෙන connector.
For what are we using connector?
Connectors use කරන්නේ data flow කීපයක් තියෙද්දි ඒ flows කීපය එකට join කරන්න. Data flows කීපයක් තියෙද්දි flow කීපය එකට join කරන්න තමයි use කරන්නේ connector. Right? Okay. Symbols are start, stop, process, input, output, process, decisions, data flow, connector. These are the standard symbols. Can you quickly draw this?
Yeah. Yeah, can. No. After we finish this lesson, I can draw it from the video you are going to give me.
All right. Okay. Then
I think
let's
that
do.
easy
Okay, let's do small exercise and try to identify these areas like input, output, processes, decisions, and data flow. And after that, let's draw one flow chart and see whether we are okay with that. I'll use a new page. Okay, my
So then
question
we
is,
should, uh,
sorry?
uh, so then I should take space for the previous notes, no?
Yeah, yeah, you have to keep some space to draw the symbols. These are the symbols, flow chart symbols.
Yeah. Before that, uh,
Before that also you have, it's only half a page, not that much even, small area, right?
okay.
Right.
Oh,
Okay, then,
again, yeah. Okay.
yeah, let's move to the question quickly. Question is this. Question number
Uh-huh.
one. Let's draw a flow chart to input three numbers and find the total and display it. Okay, here you have to identify inputs. So what are the inputs? Input three numbers. Three numbers are the inputs. Three numbers means you can say number one, number two, number three. So typically, so we use names. We use like we call that actually identifiers. Typically, we use identifiers to show these inputs, outputs, processes to show that we are using identifiers. So there are some rules showing these identifiers. The identifier should be started with a capital or simple letter. So I'll give the identifier rules first. This is not relevant to the question. Therefore, I'll write it here before the questions. Identifiers means names given by us to show inputs, outputs, processes, functions, etc. So these are called identifiers. So the rules must start with a simple or capital letter. Cannot use special symbols. Cannot use special symbols. Then cannot be started with a number, but can use numbers in the middle or at the end. So these are the rules. Must be started with a simple or capital letter, cannot use special symbols, cannot be started with number, but can use numbers in the middle or at the end. මුල හෝ sorry මැද හෝ අග use කරන්න පුළුවන් numbers මුලදී number වලින් පටන් ගන්න බෑ. No spaces allowed. Spaces තියන්න බෑ. ඒ කියන්නේ මට ලියන්න බෑ මෙහෙම number 1 number space 1 කියලා ලියන්න බෑ. කෙලින්ම නම්
Uh,
ඊළඟට first name
these are the
කියලා
rules, no?
sorry.
These are the rules.
Yeah, these are the rules. These are the rules. Then cannot use keywords. Keywords means reserved words. Reserved words. For an example, so here you show that අපි previous අපි කතා කරා මෙතන දැන් start stop කියන්නේ reserved word එක. ඉතින් ඒ වගේ වචන අපි ආයෙ use කරන්නේ නැහැ. Input output කියන්නේ reserved word වගේ. ඒවා අපි use කරන්නේ නැහැ. සාමාන්‍යයෙන් මේ ටික දෙනවා. මේ ටික reserved word කියලා දෙනවා. Normally when we are learning about the language, that language developer they provide reserved. These are the reserved word. You cannot use these words. For an example, if you go and try to create folder in Windows computer use by naming com1. මේ com1 කියලා ෆෝල්ඩර් එකක් හදන්න හැදුවොත් Windows computer එකක හදලා බලන්න ඊළඟ දවසේ පුළුවන් නම් හදන්න දෙන්නේ නැහැ. ඔය ෆෝල්ඩර් එකක් හදුවොත් con කියලා හදන්න දෙන්නේ නැහැ.
why?
So these are reserved words. ඒවා reserved Windows වලින් reserved words විදිහට තියෙන්නේ. ඉතින් ඒවා අපිට පාවිච්චි කරන්න දෙන්නේ නැහැ. හදලා බලන්න com1 කියලා හදලා
ඒ
බලන්න.
කියන්නේ
sorry.
ඒ කියන්නේ සර් මොනවාද මේ
ඒවා
ඕවා
විශේෂයෙන්
මේ කියන්නේ
communication port වලට එහෙම com1 com2 com3 කියලා communication ports වලට වෙන් කරලා තියෙනවා මේ වචන. ඒ වෙන් කරපු වචන අපිට පාවිච්චි කරන්න දෙන්නේ නැහැ.
ඔය මේ ප්‍රෝග්‍රමිං වලට කියන්නේ ඇත්තටම බැලුවොත් එහෙනම් ප්‍රෝග්‍රමිං කරන්න දෙන කීවර්ඩ්ස් නෝමල් පාවිච්චි කරන්න බෑ.
programming වලදී දෙනවනේ keywords. දැන් program වල print කියන keyword එක. print කියන keyword එකක් නම් අපිට print කියන එක අපේ වචන අපේ තියෙන තැන් වල පාවිච්චි කරන්න බෑ. අපිට කියන්න බෑ print සමානයි 5යි. print සමානයි 2යි කියලා අපිට ඕන තැන් වල පාවිච්චි කරගන්න බෑ. print කියන එක පාවිච්චි කරන්න ඕන print කරන තැන විතරයි. start කියන keyword එකක් නම් start අපිට තැන තැන පාවිච්චි කරන්න බෑ. start පාවිච්චි කරන්න පුළුවන් start වෙන තැන විතරයි. Understood? That is only for the particular place only. වෙන කොහෙටවත් බෑ. අර අතන්ට විතරයි. start වෙන තැන විතරයි. end එක end වෙන තැනට විතරයි. හරි? So that is how the reserved words are used. You have to use carefully. You can't use everywhere. Then cannot use keywords or the reserved word, and so there's a special symbol called underscore. So that can be sorry, underscore can be used. So this is a special one. Underscore can be used. For an example, you can tell number underscore 1. That is allowed. Right? Or you can even start with the underscore. You can say underscore number 1. That is also allowed. So this underscore, even special symbols are not allowed. This is exceptional. Underscore is allowed. Right? So that is how you define keywords, or you define identifiers. So num1 is identifier, num2 is identifier, num3 is identifier. Then how we calculate the total? What is the process? Input 3 numbers and find the total. How to find the total? You can say total equal num1 plus num2
plus num3.
That is the total. So what is the output? Total is the output. So any decision? No, you don't have any decision. So this is how the data flow happens. Then you have to show that in the diagrammatic view. So means, so you start with the standard starting symbol. This is start. Right, then okay, start. After that the next one is input number 1, number 2, number 3. You can put this symbol and say input number 1, number 2, number 3. Right, so then you have taken the input, then process. In the process you can tell the same thing. Total equal number 1 plus number 2 plus number 3. That is how you calculate the total. And then you have to display the total. To display total, you need output. Use the same symbol. You can say display total. Here is same name which is used here. Total metana capital T dala liwana metana liyannath ona capital T total. num1 num2 num3 mulata capital dala liwana digatama liyanna one. Then end of this process you can tell, okay, now we are done. now. So you have to stop the program. Stop the program. That's how you draw this flow chart. And data flow, you have to show data flow by using arrows. This one
Yeah.
again.
Sir, give me a second. My connection is something wrong.
All right, right, right.